a few words on intensity. Assume we have a wave source producing 100 joules per second of power. Okay, 100 watts, in other words. It could be a light, 100-watt light. It could be a sound, 100-watt speaker. Producing the wave in such a way that it's produced uniformly, symmetrically, in all directions, so that the wave spreads out uniformly in all directions. Then the total power is going to pass through concentric spheres. Okay, any sphere of radius r about the center is going to have 100 joules per second of power passing through it, 100 watts of power. That 100 watts is going to be spread over the surface of the sphere. So the 100 joules spread over the surface of a sphere, well, the area of a sphere is, surface area of a sphere is 4 pi r squared. Excuse me, the intensity, therefore, is 100 joules over 4 pi r squared, or in general, we could say just the power over 4 pi r squared, because we could have different power sources. It's not always 100 joules. So that's how we define intensity. It's power over area. So intensity in this case is inversely proportional to the distance from the source, to the square of the distance from the source. How in the world did I leave that out? To the square of the distance from the source. Now, we have this scale for measuring loudness of sound called the decibel scale. First of all, let's make a definition. I naught, threshold intensity for a sound, is 10 to the negative 12 watts per square meter. That's the lightest sound that a typical, healthy, young human being can just barely detect. Okay, 10 to the negative 12 watts per square meter, or say a watt spread over a trillion square meters, if you wish. A trillion square meters would be a million meters on a side, which would be 1,000 miles on a side. That's kind of interesting. Okay, did I do that right? You check me. Okay, decibel. The decibel scale for an intensity I, the number of decibels is 10 multiplied by the log of I divided by I naught. In other words, if a sound is, let's say, 100 times the hearing threshold, then the log of I over I naught, and log is base 10 log, well, I over I naught would be 100. The log of 100 is 2, and 10 times 2 is 20, so you'd get 20 decibels. Very simple calculation, and you should understand logs. If you don't, review it and never forget it again for the rest of your life. Okay. Now, let's just do one quick thing with this. What do you get if you solve this for I? In other words, if you know the decibel level, let's say a sound is 58 decibels. Now, that's probably around where my voice is right now, 58 decibels. That's kind of what I'm aiming for. Okay, we got a 58 decibel sound. What's the intensity of that sound? Go ahead and work that out on your own, but let's come back and go ahead and do it now. Okay, well, I can rearrange this equation. I can say that the log of I over I naught equals the decibel level over 10. And then I take the inverse log. The inverse of the log is raising to the 10th power, 10 to the power. So 10 to the log of I over I naught is I over I naught. That's going to be 10 raised to the 1/10 of the decibel level, so that the I is I naught times 10 to the number of decibels divided by 10. So my 58 decibel sound, 58 divided by 10 is 5.8. Take 10 to the 5.8, multiply that by 10 to the negative 12 watts per square meter, and you have the intensity.